hello everyone, and welcome to the Climate Dialogue Winter Speaker Series being hosted by the University of Washington Bothell and Cascadia College. We share a campus, so we work together often. We're really excited to bring you guys this speaker series tonight. A little bit about the University of Washington Bothell Office of Sustainability. You can find our contact information on this slide if you are interested in keeping up with us. We also have a student club on campus. So if you are a University of Washington Bothell student and interested in sustainability, you're welcome to join our club, the Alliance for Sustainability Club. We also have some other upcoming events. We have more events in this virtual speaker series coming up next week and in 2 weeks. We also are hosting a lot of events for Earth Month in April. So again, follow us on social media and contact us at the email on the slide if you're interested in hearing more about those events. Cascadia College is our counterpart, and I will let Stefan talk a little bit about the Cascadia Sustainability.
Hi, everybody. So Cascadia College, as we said, we're a joint campus, so we work really well together. We're a smaller 2-year institution, and we have a bachelor's degree in sustainable practices. Our social media and other contact information is there below, and you can find information online for some of our activities and things. Just some of the highlights of Cascadia and our campus in general as a whole is that our campus is the #1 campus for sustainable grounds in the nation. And we are 100% pesticide-free and permaculture practices. So it's something really that we're happy to be proud of our campus for both UW Bothell and Cascadia College. That said, we also have a student club and other ways to participate. So please just follow our social media or contact us by this email.
Thank you, Stefan. I'm now very excited to introduce tonight's guest. Tonight's guest is Merri Metcalfe from the Washington State University BreadLab. Merri Metcalfe is a PhD student at the Washington State University, but she works with the WSU Breadlab under the mentorship of Dr. Stephen Jones. Her research focuses on accessibility, quality, and affordability of grain-based products from Western Washington, and on breeding for increased fiber content in wheat, along with subsequent health and cropping food system benefits of doing so. So her talk tonight is going to be focusing on how climate change is affecting the nutritional profile of wheat. And I am so excited to turn the floor over to Merri.
Hello, thank you, Rachel. Well, thank you for having me. Like Rachel said, I'm working on a PhD in crop science at WSU Breadlab, and we are not Eastern Washington. We're not in Pullman. We're actually kind of close to you all. We're about an hour's drive north of Seattle, maybe an hour and a half, depending on traffic, in Mount Vernon. So we're in the Skagit Valley here. And like Rachel mentioned, I have a background in nutrition. So I worked as a registered dietitian for 8 years prior to beginning work at the BreadLab, and then was really brought to the lab to work on the nutritional side of what we do in sustainable agriculture. So our lab was founded by Dr. Stephen Jones in 2009. He was originally the winter wheat breeder in Pullman, Washington, and so he worked as the winter wheat breeder since 1991. And then in 2009 was given the opportunity to become the director of the research station in Mount Vernon, so the agriculture research station here. And the mission of our lab is really to increase the affordability, accessibility, and approachability of whole wheat baked products for as many members of our community as possible. And so we started as a traditional wheat breeding lab, and what that means is basically that we are the folks creating new varieties of wheat that we started, and now we've evolved to more grains. And when we say wheat breeding, we're not talking about GMO or gene editing. What we do is traditional crosses. And so this means that it's actually pretty kind of old school and simple. We go into the greenhouse and we take two wheat plants. One, we remove the female parts, another we remove the male parts, and then we shake them together and create a new variety of wheat. And we focus on populations and land races, which I'll get a little bit into the nitty-gritty of what that is later, but For now, the main thing to realize is that that means that we leave genetic diversity in the varieties of wheat that we produce or we release, whereas sort of wheat bred for the commodity system or the global market, which wheat is sold, has to be a pure line, meaning that there's genetically identical. And then we are also an organic wheat breeding lab. So all of our wheat is bred for an organic farming system. And we often call our lab out of place. And this is for a few reasons, but for one, whenever people think of the Skagit Valley, they don't usually think of wheat. We often think of wheat when we think of Eastern Washington and the Palouse or Kansas or Nebraska. But then also kind of when Dr. Jones came to Skagit Valley, he kind of thought, maybe I'll stop breeding wheat. Maybe I'm going to get into a different crop because there's over 80 crops grown in our valley, and wheat and barley are number 79 and number 80 as far as value is concerned. So the high value crops are tulips, people think of potatoes, berries, raspberries, spinach seed, but people don't usually think of Skagit Valley as being a grain growing area. However, once he came here, he started meeting with the farmers in the area, and they kind of consistently said, no, we want you to work on the grains. We want you to work on wheat and barley because we have to grow these grains as a rotational crop to break disease cycles and add nutrients back into the soil, but we're losing money on them. And so they wanted Dr. Jones to bring value back to these crops. And so that's kind of how the Bread Lab was born. And I have a couple quotes here of farmers that we work with. So one of them said, when I grow wheat, I just want to lose less money. Another said, I grow wheat for fun and sometimes profit. And so we take pride in being out of place, but then it's kind of worked out that wheat actually is quite in place in Skagit Valley. And so I mentioned that we breed wheat outside of the commodity system, and this is somewhat unusual for wheat breeding programs at land-grant universities. However, we've found a lot of freedom in doing this. And for one, when you breed for wheat within the commodity system, it has to meet precise set of standards. It has to be like a certain size. It has to yield a certain amount. It has to be red or white. It also has to be either soft or hard. So if wheat doesn't fit that classification, it's not really valued within the commodity system or the global market for wheat. And so we think that we can find value in lots of other types of wheat, and we don't want to be limited by those. And then we also realize that if we breed outside of the commodity system, we can keep value where it's produced, is what we like to say, by selling directly to our community. And so another kind of aspect of what this allows us to do is to establish our own breeding targets. And so you'll see here this image of, this is actually blue wheat. This wouldn't be, you're not able to sell this on the commodity system, but we think there's value there and it's beautiful. We do focus on yield. So yield is a primary breeding target. If something doesn't yield well, we'll throw it out. Because we have to, yield allows it has to work for the farmers first and foremost. And then we also, having a high yield allows us to bring the price point down so that the varieties that we release are accessible to as many members of our community as possible. And then second to that, we breed for flavor. Everything that we grow in the fields, we test bake in our lab here. And then we also breed for nutrition, which is sort of my focus. And which ties into the fact that everything we breed for is bred for whole grain uses, which also makes us unusual. We given that we're breeding out to the commodity system, like I mentioned, we have the opportunity to do more sort of fun curiosity types breeding work. So we have a student working on purple wheat and barley and blue wheat and barley, and then also perennial wheat, which is a really hot topic right now. And we're really proud of the fact that since our lab's presence has contributed to the creation of a state-of-the-art malting facility, Skagit Valley Malting, which is right next door to us. It's actually the largest craft malting facility in the US ×3, as well as 2 flour mills, several breweries, According to the executive director of the Port of Skagit, here where our lab is located, Patsy Parton, it's also led to the creation of over 250 living wage jobs. Now I'm going to switch gears a little bit and talk about what flour is. This is an image of our wheat breeding, or they're all types of grains there, but our grain trials in Skagit Valley, an aerial view. So you can see that there are little plots there, and you can see the diversity. And here, one thing that you notice is like some varieties here are earlier to harvest and others are later. So those are different traits we look for. Sometimes we'll see that one of those plots might be covered in stripe rust and everything else is resistant to the disease. And so we know that we're going to throw out that plot that has stripe rust. So that just kind of gives you a sense of what our trials look like. And then we also call ourselves plant breeders who bake. And this is just because everything we grow, we test bake ourselves. And then we also work with whole grains exclusively. So, oops. I'm going to switch gears to talk about why we do that. And when we think about flour, we're usually thinking about white flour. And for all intents and purposes, white flour is flour. And flour is compromising human health. We know that as far back as 1907, Norwegian sailors were getting sick with beriberi or thiamine deficiency due to eating an exclusively white bread diet. Currently, 98% of Americans don't eat the recommended intake of whole grains, and 74% exceed limits for refined grains. And then as far as breeding targets go, I think it's safe to say that essentially every wheat breeding program in the US and probably the world works on white flour as a main breeding target. The point here is like, there's a reason why whenever we go to Panera Bread or the grocery store or any sort of place where you find a product made with flour, it's usually made with white flour. And that is because it was designed that way by breeders. This is just an image here of a white flour biscuit compared to a whole wheat flour biscuit. This is a graph from the American Journal of Clinical Nutrition, and we see total carbohydrate on the left, and then carbohydrate from fiber on the right over time on the x-axis. And what this is suggesting is a dramatically increased intake of refined carbohydrates over time. This sort of empty space here is a visual representation of what has been termed the fiber gap. And this illustrates the fiber gap in the United States, but it's not strictly an American phenomenon. It was also recently shown in the Eat Lancet Commission paper to be a global phenomenon. Now, the fiber gap is referring to inadequate intake of fiber in both the US and worldwide. However, the US recommendations for fiber intake actually aren't that high. They're 28 to 34 grams per day, which for reference, there's about 5 grams of flour or of fiber in 2 slices of whole wheat bread. However, we know that 94% of Americans don't meet fiber needs. And whenever I say this, I always like to really emphasize the fact that we're not talking at the individual level here. So it's important for me that you all realize I'm not trying to like shame somebody for eating a pancake or shame someone for eating a slice of white bread. We're really talking about a systemic issue and getting at the point of like why white flour is so prevalent in our society, and that this is something that we can perhaps change through a shift in our food system. And then why do we need fiber? And so to get a little bit into the nitty-gritty of the human nutrition side, there has been sort of a trend of the gut microbiome health, and that is exciting. There's a lot of research being done in this area, but just a basic kind of intro. We need dietary fiber in our diet to make short-chain fatty acids in our gut, including acetate, butyrate, and propionate. And these short-chain fatty acids play a role in regulating our metabolism, and also our immune system. So the basic idea is that if we have a diet low in fiber, this leads to decreased microbial diversity in our gut, which leads to a deterioration of our mucus layer and then an increased risk of developing chronic inflammatory diseases, specifically diabetes, colon cancer, and then inflammatory bowel disease are the big ones. And then alternatively, if we have a diet high in fiber, this leads to more diverse and abundant short-chain fatty acids in our gut, which leads to more improved immune responses and decreased risk of these chronic diseases. Now, this is from the Global Burden of Disease study, which was published by Lancet in 2019. And this was from research at UW, actually, and funded by the Gates Foundation, but they found that low intake of whole grains was the leading dietary risk factor for mortality among women and the leading risk for death and disability-adjusted life years among young adults. And then they quote in the paper, our findings will inform implementation of evidence-based dietary interventions. So we take this to mean at our lab, or we believe that it's our job as breeders, me as a dietitian, to intervene here. And what does this mean for the work at our lab? Just to summarize, flour containing a higher percentage of the whole kernel has a positive impact on human health. This is a fact, hundreds of references say this. And then the second side, which is not thought of as often, is that using the entire kernel models best use of the land and actually equates to a higher yield of human food per acre because we're not removing that outer layer, that bran and germ, which I'll get into a little bit of that in the next few slides. And then finally, breeders can increase accessibility. And so I think that I like to think of it as plant breeders, wheat breeders have a power to influence what's available within a food system by what we choose to breed for. We're sort of we're involved at the beginning stage of when the seed is being developed. And so we can use this power to increase accessibility. So with this sort of great power comes responsibility, or I would say an obligation, to breed with human health in mind and to breed for whole grain flour and whole grain uses. This is a picture of a miniature roller mill, which we have in our lab, in our milling laboratory. And I wanted to show you this because it gives you an idea of the scale of sort of the systemic problem that's going on. So, and to just back up, wheat or any kind of grain that goes through this series of rollers. This is a roller mill. And then under here is a sieve, which separates the bran and germ, which is in this brown drawer, from the endosperm, which is the white flour here. And we know that essentially all of the nutrition is in this brown drawer, yet this is what is discarded as waste or animal feed. We have all the fiber here, all the B vitamins, all of the minerals, iron and zinc. My advisor, Dr. Jones, likes to say that this white drawer here has about the nutritional content of a Q-tip. And another way of thinking about this is like the consolidation of flour production. So 100 years ago, we had 25,000 flour mills in the US. Now, 19 mills produce enough flour for every one in the United States to have an average of 165 grams of flour per day. So again, this is just really highlighting the scale here. This is just an up close of those rollers. And then I also wanted to show you, this is the inside of a stone mill, which we also have in our milling laboratory. And this is about, these stones are about 26 inches. And usually they're next to closed. So this is opened up just so you can see the inside of the stone, but usually they're close together. And one of the stones will be stationary and the other turns and grinds the flour. And so grinds the wheat kernels. And so those are put in from the top. And this is becoming this is an old way of doing it. And it's kind of making a comeback and becoming a little bit trendy again. And we prefer this way of milling because there's no sifter, at least in our mill. So if you put 100 pounds of wheat kernels in there, you get 100 pounds of flour back. Another aspect that is important to touch on is that oftentimes wheat kind of gets a bad reputation in the health world. People kind of think of it as not healthy, but it's actually contains a wealth of nutrients and is very nutritious. And the starch and proteins are what we think of typically when we think of wheat, but there's also many other nutrients in there. So we have minerals, B vitamins, which you might be thinking, but they just fortify those back in. And the reason they fortify the B vitamins back in to enrich flour is because they're removing it, and they noticed that there was problems with that. But that's sort of a side note. We also have phytochemicals, phenolic compounds, antioxidants, fiber, which is the focus of my work, and then healthy fats. And then to kind of emphasize this point, but what's inside a kernel of wheat, in this endosperm here, when we remove the bran and germ, we're left with only the starch and proteins. So to really make that point, all of everything that we lose when we sift flour is highlighted here in red. This is an image of our seed room. So this is in the back of our lab, and there's over 1,500 varieties of grain here. And this is where we get all of our germplasm to begin the breeding process. There's wheat on the right side, and the back is barley and rye, and then we have buckwheat and beans on the left side here. And this is just an up-close image of some of the varieties here. And I mentioned that we're doing different colors of wheat. So these are work of one of our students, Robin Morgan, is working on. So there's a blue wheat, a dark brown, kind of a burgundy color. All of these are types of wheat that would be rejected within the commodity system. And so we, once again, find that breeding outside of the commodity system allows for freedom, novelty, curiosity, discovery, all these beautiful things. And we are proud of the fact that we get to get creative. This is just close-ups of the wheat. And I think being at a lab like this, you really start to appreciate the beauty of the seed. And this is an example of that. We don't really, it's often easy to forget how beautiful a seed is. This is the colored club wheat that Janine Sanguin, our director of special projects, is working on. Another aspect I think that is special about our lab is that every member has something in the field. Every member of our lab is working on breeding in some way, even our managing director. And we think it's important that everybody understands the breeding process. This is some non-commodity barley for whiskey distilling. So that one's really beautiful in the lab when it's drying off, that purple colors. Again, this wouldn't be able to be sold within the commodity market, but our student Louis Prager is working on this for Westland Distillery, actually, which is the distillery in Seattle. And this is buckwheat. We also work on buckwheat, a little more buckwheat. I like this image. We call this our buckwheat jungle. Buckwheat's actually a relative of rhubarb, so you can kind of see the similarities there. And then we work on beans as well. Then now switching gears to this idea of the diversity in the field also leads to diversity on our plate. And we favor land races that leave genetic diversity in the varieties that we raise as a way to respond to a chaotic climate. We also have miniature professional baking equipment in our lab. So this allows a professional baker to come to the lab and feel at home to test bake with everything that we grow. And so here are some images of the whole wheat products that we make in the lab. And this is, let's see, a 100% whole grain croissant or baguette, and then 100% whole grain loaf of bread, which is a project we're working on called the Approachable Loaf, which I'll talk a little bit about in a minute here. This is our director, Dr. Stephen Jones. making some 100% whole grain pizzas in our World War II buoy oven. That was, I mentioned Janine Sanguin, who is our director of special projects. This was one of the special projects she got to work on, which was building this buoy oven, which is actually made from a World War II buoy. It's insulated with whiskey bottles, which is kind of fun. And here are some 100% whole grain bagels that were made in the oven. This is 100% whole grain croissant, which does take a lot of skill. This was baked by Jeff Yankelo, who's been a friend of our lab and big supporter. He was actually, his kind of claim to fame is he was on the winning team of the Coupe du Monde de Boulangerie, which is like the World Cup of Baking or the bread baking Olympics for the US. And then this is also 100% whole grain biscuit. We also do pie crusts and cookies. Now switching gears again, away from the pretty food photos to a little bit more of the climate side of things and research. When I came to the lab, Dr. Jones wanted me to focus on increasing fiber in wheat and trying to breed for a double bran layer. So if you remember that picture I showed you earlier of our seed room, breeding starts with the germplasm. So what I did when I first got here was just going in that seed room, spending hours, taking a razor blade, cutting open the seed and just looking with the magnifying glass. Does it look like there's a thicker bran layer there? So I spent hours in there looking at over 500 varieties, found none. Well, actually I found two. I grew both of those out for 2 seasons and both of them got annihilated with stripe rust. So they just weren't good varieties to start with for breeding for the Pacific Northwest area. And so I was kind of at a loss. And then one day Dr. Jones came into my office and he's like, Merri, you've been spending all this time trying to breed for a double brand. How's that going? I was like, well, it's not going too well. He's like, what if instead of trying to breed for a thicker bran layer, you tried to make a smaller endosperm? And so that's kind of like where the beginning starting point of this project came from. And we started looking at the economic and nutritional value of smaller wheat kernels. If you see in this image here, this is the same variety. One kernel is larger. 1,000 kernel weight is the term that we use in the breeding world, which just refers to the weight of 1,000 kernels. So it's pretty simple. And on the left, the 1,000 kernel weight is 42.7. On the right, the 1,000 kernel weight is about 25 grams. So we labeled this lighter one was a small, and the bigger one, the heavier one was the big. And typically, bigger kernels are valued because they create more white flour. And so this whole project was a way of reframing what we value in our grains. And we know that average 1,000 kernel weight has increased by about 2.2 grams per decade, with an average 1,000 kernel weight of around 32 grams in the 1940s to an average 1,000 kernel weight of around 45 grams in the 2000s. And larger kernel size results in greater white flour yield. And then this remains a primary breeding target. And then this increase in 1,000 kernel weight is a direct result of plant breeding. Meanwhile, climate pressures are producing yields in locations where the kernels are significantly smaller. So we've seen that smaller kernels form in response to inhibited starch deposition in the growing process from heat and drought stress. And we're also know that this isn't going away. It's only going to get worse. We're finding each year that we're seeing more and more variation in the growing conditions and more dramatic heat and drought conditions. Now, stepping back, this idea brought us back to something called the square cube law, which was actually a principle described by Galileo Galilei in the Two New Sciences, where he states the surface of a small solid is comparatively greater than that of a large one, which meaning that as the volume of a shape increases, the surface area of the shape decreases relative to the increase in volume. So it's a really simple concept in relation to a wheat kernel. If the wheat kernel gets bigger, the outer layers going to get smaller. So that's where this idea came from. Given that 98% of dietary fiber in wheat is found in a bran, we can infer by principles of the square cube law that small kernels contain more total grams of dietary fiber per kernel than large kernels. And we decided to test this. So we took 9 different varieties of wheat and we separated each variety into smalls versus bigs. And we did this by using a shaker, which had a sieve, which is the same size that commercial seed cleaning facilities use. And they typically remove the smaller kernels and then sell those as animal feed. But we wanted to show that actually this could have value as human food. And so we separated the varieties that we grew in our trials by smalls and bigs, and then decided to run them through that roller mill I showed you earlier, that miniature roller mill. Weighed out the bran that came off and the white flour that came off, and determined the percentage of bran for the big seeds versus the small seeds, and found that on average, the smalls had about 15.9% more bran. So we infer more fiber, more minerals, more vitamins than the bigs. And then once we had determined that, we needed to bake with them and say, can you make desirable bread with these small kernels? And we found that yes, you can. So this is an image here. These are miniature loaves. So 3 versus 4 is the same variety of wheat. 4 is the smalls and 3 is with the big seeds. 5 is a different variety with the big seeds, baked with big seeds, and then 6 is the smalls. So on average, we found about a 2 millimeter difference, which in talking to commercial bakers, we're told that that's about a negligible difference. And then here, when we did this test with full-size loaves, this one was kind of interesting. This is actually sent to us by a commercial craft mill, and it was labeled chicken feed. It was their actual small kernels that they were rejecting or selling as animal feed. And we baked with it, and we found it to make some really great bread. And this is compared to a variety of Skagit 1109, which is a landrace variety, like I mentioned earlier, where we leave the genetic variety in the grain. So this is one that we've found bakers really love, and it did just as well as this chicken feed. So we were happy with those results. And a little side note on Skagit 1109, I don't think I mentioned earlier exactly what that meant. So it's a landrace. Like I said, our lab favors landraces. And the cool thing about leaving genetic diversity in the varieties that we release is that if we grow that variety in Washington, for example, and then grow it in Montana, it may end up looking very different several years down the road, because the genetics that work well in Washington may be different than the genetics that work well in Montana. And so that's a neat approach to breeding, and we've favored it, and it's worked well for us. And then we published this work in a paper called Climate Changed Wheat, the Effect of Small Kernels on Nutritional Value of Wheat. Back to that approachable loaf that I mentioned earlier. This has been an exciting project, sort of an outreach project that our lab has been involved in. It came about by 2 different sort of things that came to our attention. One is this, you'll see this grocery store loaf here. This had a sell-by date of June 3rd, 2018. And this picture was taken a year and a half later, and it was still soft and squishy. We no longer have the loaf in our lab because the plastic started deteriorating faster than the bread. And so that's kind of a problem. And the question is, why is it like that? Most grocery store breads have over 26 ingredients. Typically, we only need 4 ingredients to make bread. So we need flour, water, salt, and sourdough starter. But why do commercial bread industry have so many ingredients? They're basically removing the ingredient of time. So they add emulsifiers and additional wheat gluten, as well as preservatives, to be able to make more bread in a quicker amount of time. And then the other side of this is that we, prior to the pandemic, were doing several workshops of sort of artisan baking teaching people how to do artisan baking. And at the end of these workshops would have lots and lots of those hard, crusty loaves left. And then we would take them to the food bank. And then after a while, they actually told us, can you stop sending those loaves? Like, nobody takes them. They're not, people don't really want them. They're dry. And we realized that that's really not, a lot of people don't want those crusty breads. What we think of as bread in the US is often that soft, squishy loaf. And so this approachable loaf is trying to, one, provide an alternative to the grocery store loaves with over 26 ingredients, and then two, provide a way to kind of bridge that gap between those artisan loaves and that soft and squishy loaves that a lot of people prefer. This one I kind of touched on already. This is just a slide showing you what's in all those additional ingredients and why they're there. Most of them are there to either preserve the bread, to cause it to ferment faster. So industrial bread making does not use long fermentation. They use a lot of additives to do that for them. And this was sort of started the birth of what we've called the BreadLab Collective. And this is a formula that's really available on our website if you want to try making it at home. We have a video on how to do that as well. And the key is that there's no more than 7 ingredients and no non-food. So our recipe has flour, water, salt, sourdough starter, like I mentioned earlier. We also add a little bit of honey to preserve the shelf life, and then some olive oil to soften it up, and then a little bit of pinch of yeast as well. You don't have to use the yeast if you don't want to, though. And then it's if bakeries are selling it, they need to be 60 to 100% whole wheat. Personally, I'm kind of the hardcore whole wheat one in the lab. I favor the 100%, but we do the 60% as a way to kind of compromise and ease in to the whole grain for bakeries. Sometimes it's easier for them. And then it also has to be priced under $6 a loaf. And we're proud of the fact that this bread is now being baked in bakeries in 29 states and 6 countries. If you're interested in learning more, we have recipes and videos on our website, which I put up here. And then we also have an Instagram account that is pretty active as well. I wanted to touch a little bit on the other graduate students here at the lab. I mentioned Robin. He's Italian American, and he's working on the perennial wheat and breeding purple, blue, and black wheat. And then he's also working on a spherical wheat, so a different shape rather than the oval, a spherical wheat. He is funded by Sandy Arrow Ranch in Montana. Laura Valli is an Estonian and is working on rye. She is an anthropologist, and her dissertation is looking at the meaning of rye, and she's funded by King Arthur Flour, who is a really big partner of our lab. They actually have a baking school in our lab area, so we get to collaborate with them a lot. And then finally, Louis Prager, who I mentioned earlier, he started his career with making a bakery in Carlsbad, California, called Prager Brothers. It's still running, but he is now working on a PhD breeding barley for whiskey distilling, and he's funded by Westland. Finally, one important aspect of our lab, or something that we're kind of always asking ourselves, is what is the role of public servants? And it's important that as students that we're involved in the community in some way. And for me, this has been taken on the looks of as a course called Whole Grain Researchers. We had one of the principals in Bellingham reached out. I think she's a principal at a middle school there, reached out to us during the pandemic and said, our teachers have to have these STEM continuing education credits to keep their teaching credential, but no one is offering them. And would you be up for teaching a class that meets these continuing education requirements? So we designed a course called Whole Grain Researchers, and the first rendition was virtual. So we had an hour-long course every Tuesday for a month, and then we had over 120 teachers participate, which was exciting. And then last August, we did the first in-person rendition. And many of the teachers told us it was their favorite professional development course, which is exciting. And so we're really hoping to expand this program and do more of these in the future. And we've also been involved in doing Bake for Good and Friendship House Bake. So we try to bake 100 loaves to donate to the food to the Friendship House each month. One of the King Arthur bakers baked over 6,000 approachable loaves during the pandemic, which was amazing. So we're proud of this work, and we are trying to be involved in the community. And another final example of this was a project that we just started last November called Pizza for Producers. This was in conjunction with our extension office. They sort of led the charge for this, and then we helped with the teaching of how to make a pizza oven. But the idea was that they were noticing that the growers they were working with are having sort of need for stress reduction. And so the idea came about to teach farmers how to make pizza ovens, and that they could have on the farm and kind of host community building events. And so we did the first rendition of this in November. It was featured in the Seattle Times, and are now taking it to the next level where the extension agents are bringing it to their farmers. And we're excited about the future of this. But there is a cool book if any of you are interested in trying to build your own oven, called Build Your Own Earth Oven, a low-cost wood-fired mud oven. So that might be fun for folks to look into. We, as a final ending note, we like to say we have partners, not donors. So this is a partial list. It's always changing of the people we partner with. And we also like to say that we only partner with people we don't have to apologize for. So everyone on this list has the same ideas in mind. They're climate friendly. Other than the whiskey, they're affordable. They range from the bakery north of the Arctic Circle in Sweden, Pullabrod, who in their words was a 150 woman-run bakery, to Grand Central in Seattle, maybe many of you are familiar with. We have our wheat on the farm at Yale University, and I believe we're also on the University of Washington recently. So you have to let me know if that's correct. We have an endowment with Cliff Bar and King Arthur. So thank you to these partners. And then I'll close with this. This was from an anonymous artist in Nottingham. So we had a baker, Kimberly Bell, visit to do a sabbatical here at our lab, and she brought us this note, "Whose bread is this?" And I really liked the quote that she brought with it, and I thought it would be a kind of good ending note. So she says, "Increasingly, there is much to question about who holds power, who are custodians of our seed, who gets to give them out, who controls the infrastructure to turn them into food, who labors to do the work, who decides how knowledge is disseminated. How does that all filter out to ensure that everyone is nourished? Things got really complicated. It's going to take all of us to wonder whose bread is this." So thank you. And
thank you so much, Merri. That was an incredible talk, and I certainly learned a lot. So I hope that everyone else did as well.